The multiplication rule in modular arithmetic is very important for proofs in modular arithmetic. Good day, future educators! Today is another report under our subject, which is the abstract algebra. I am Vina, Amor, Gaston, and I am in partner with the amazing Miss Regina Jaum. And together, we will have a discussion with proofs in modular arithmetic as we decided. Now, let us start. For introduction, let me define first again what is modular arithmetic. This is a system of arithmetic for integers that considers the remainder. In modular arithmetic, numbers wrap around upon reaching a given fixed quantity, and this given quantity is also known as the modulus, to leave a remainder. Modular arithmetic is often tied to prime numbers, for instance, in Wilson's theorem, Lucas' theorem, and Hansel's lemma, and generally appears in fields like cryptography, computer science, and computer algebra. Now let's proceed with our main discussion, which is about proofs in modular arithmetic. We will present 3 proofs. My partner and me will present 3 proofs, and I will be the one to present first, and my partner will continue the rest of our presentation. Now everyone, let us continue. So in my presentation, we have a proof here. So to do this proof, we are going to need these 2 identities here. You can see that in my presentation. First, we know that if P is congruent to Q and Q is congruent to R, then P is also congruent to R mod N. That's just for starters. This means that the congruence mod N is transitive. And the other identity is that if P is congruent to Q mod N, then we can multiply a constant on both sides. So x times P is congruent to x times Q mod N. You can see that in the middle of my presentation. Now, using this, everything, we can derive some information from our starting congruence. First of all, let's take this first congruence, A, which is congruent to B, and multiply both sides by the constant value C. If we do that, we will find that A times C is congruent to B times C mod N. Okay, so again, since we have just multiplied by that constant value on both sides, we can do similar thing to the second congruence. If C is congruent to D mod N, we can multiply both sides by the constant value of B. If we do that on the left side, B times C is BC, and on the right side, B times D is BD mod N. Notice what's happened here. We have ABC and ABC in both congruences. And because the congruence mod N is transitive, if AC is congruent to BC and also BC is congruent to BD, then we know AC must also be congruent to BD mod N. So by starting with our initial congruences and multiplying the first one by the constant C and the second one by the constant B, we are able to show that AC is congruent to BD, and that completes our first proof. So that is just my part for this video presentation, everyone, and let me give the floor to my groupmate, which is Ate Miss Regina. So take it away, Ate.
So for a continuation, let's try some more proof problems involving modular arithmetic. But first, let's talk about what is A is congruent to B mod N means. What are the following conditions? So the first condition states that A and B must have the same remainders when they are divided by N, where N is a positive integer but not equal to 1. So this means that it must be more than 1, like 2, 3, and 4, and so on. The second condition states that A is equal to K, which is our unknown number, times N plus B. And the last one, N divides A minus B, where A minus B is a multiple of N. So now let's try one example. Let's try to prove or determine if 10 is congruent to 14 mod 4. So we're going to use the 3 conditions. So in here, our A is 10, our B is 14, and our N is 4. So now we're going to determine if they have the same remainder. So 10 divided by 4 is 2, remainder 2. Then 14 divided by 4 is 3, remainder 2. So this satisfies the first condition. Next, 10 is equal to k times 4 plus 14. So our k here is negative 1. Finally, 4 divided by 10 minus 14. So we have 10 minus 14, which is negative 4. If negative 4 is a multiple of 4, the answer is yes, because 4 divided by negative 4 is negative 1. Since it satisfies all the conditions, therefore 10 is congruent to 14 mod 4. Next example, let's check congruence modulo n by multiplication proof. So in here, we are tasked to prove if A is congruent to B mod n and C is congruent to D mod n, then AC is congruent to BD mod n. So here's the proof. Suppose A is congruent to B mod n and C is congruent to D mod n. So since A is congruent to B mod n, therefore there exists an element integer k such that A minus B is equal to Kn. And since C is congruent to D mod n, therefore there exists an element integer r such that C minus D is equal to Rn. Then AC minus BD is equal to AC minus BD plus CD minus BD. So C times A minus B plus B times C minus D. So in here, A minus B and C minus D is a multiple of n. So we have C times Kn plus B times Rn. So Ck plus Br times n, where Ck plus Br is an integer y. In here, we have proven that AC is congruent to BD mod n. So this ends our discussion, and I hope you've learned from our videos. Thank you for watching.